Alright, so let us look at the other example right here. So we have number 2. It's not an example, but it's a question from 2024 test 1. Alright, so I'm just going to look at the first part, but it's pretty not that hard. Alright, so about the first part, we will have find the area for a region enclosed by the curves. We have x is equal to 2y minus y squared, and we have x is equal to y squared minus 4y. So they gave you a sketch right here. It's gonna look like this, right? So the sketch you will have, I don't know when I'm gonna try to draw it perfectly, and then we will have something like that, right? So that should be x is equal to y squared minus 4y, and then that should be x is equal to 2y minus y squared. Alright, so now we want to find the area. Okay, so the area is going to be equal to, okay, firstly we need to find the intersection, right? Because we don't have the intersections right here, it just gave us the equations only. Right, so to find the intersection, you need to equate these two curves. Right, so 2y minus y squared is equal to y squared minus 4y. Alright, so I'm going to try and simplify everything, so I move out to the other side. It's going to be 2y squared minus, that's going to be minus what? Over to that side is going to be minus 6y, should be to 0. And we take away 2y. Let's take away, okay, fine. Put 2y outside. We're going to have, so right over here, we're going to have your y minus 3 equals to 0. Okay, so 2y is going to be equals to 0, or your y is going to be equals to 3. These are the intersections that we have. Alright, so yeah, we're going to have this, right? So those are the intersections. So now, these are the y's, remember. So y is equal to 0 here. So these are your y's, remember, okay? So right over here, if you look at this value, this is your x, okay? Should be negative, and then that should be positive. And then if you look at the top part, it's going to be positive. So that is why we have 0 and 3. Because that's 0, and then right over there, which means that's going to be a 3. Alright, so about the area of this problem, alright, so we're going to have antiderivative from 0 all the way to 3. This is going to be dy because I'm using the y values that I found. Okay, so we have to say that because I'm using the y values, it's going to be right minus left. Okay, so about the right one, we're going to have, so we're going to have y minus y squared minus, and then that one, which is going to be y squared minus 4y, and then we're going to have dy. Okay, this is what you're going to have. So let's just solve this real quick. Okay, so we're going to have 2y minus y squared plus 4y. You're going to have dy. Area is going to be equal to an antiderivative from 0 to 3, right? And then what? We're going to have 6y minus 2y squared, because there is 2y squared, that's going to be 6y, and then dy. The area is going to be equal to, so when you take an antiderivative of that, you're going to get 6y squared divided by 2 minus 2y cubed divided by 3, integrated from 0 all the way to 3. Okay, this is what you're going to have. Now, let's just compute everything real quick. We have 1, we have 3 right here, and then y squared minus 2 over 3, y cubed, 0 to 3. The area is going to be equal to 3 into 3 squared minus 2 over 3 into 3 cubed. Perfectly, that is a 0. Okay, so now, what is 3 squared? That's 9. 9 times 3, that's 27. Minus 2 over 3, that should be 27, right? And then it is going to be equals to, right, so I guess that should be 27 minus it should be a 9, okay, if not mistaken. Right, so this area of question number 1, 2024. So I guess I should write that as 2024 test 1. Right, so that's 2024 test 1.